The next few videos are going to be kind of geometry based, but it's going to be using algebra to solve kind of simple entry level geometry problems. So if geometry isn't your thing, don't worry about it. I just want to show you how you can use algebra and some of the things that we've gone over so far to solve problems a lot easier than just sitting out and guessing and checking and trying to do it the hard way. So we'll cover triangles first, since we've already been doing a little bit of that. We already know about right triangles, right? They are triangles that have a right angle in them. And I have one pictured right here. That is a right triangle. Another type of triangle is called an isosceles. And the special thing about those is that two sides are the same length. So this side and this side are the same length, and we denote that, we label that with these two sticks right here. So when I see those two, I automatically know that, hey, this side and that side, they're equal to each other in length. And then the angles opposite those two equal sides are also equal to each other. So this angle and that angle have the same measure in an isosceles triangle. All right, next up is an equilateral triangle. And the special thing about these is that all three sides are equal to each other. So if this side is 8, well, that one's 8 and that one's 8. Pretty straightforward, equilateral. And then by that same token, since all the sides are the same length, the angles also have the same degree for each of them. The last type of triangle you'll see is a scalene triangle, and this is where no sides are equal to each other. So every single side has a different and unique length. And then also the angles will have different values as well. The only difference between a scalene and a right triangle is that the right triangle, one of its angles is 90 degrees. The most important thing to know about any triangle is that if you add all of the angles up together, you're going to get 180 degrees every time. So if I added this angle, and that angle, I'll get 180 degrees. If I add this angle, and this angle, I'll get 180 degrees. This one, I'll get 180. If I add that, and that, I'll get 180. So if you add all of the angles inside of a triangle, you're always going to get 180 degrees. All right, and the last thing I'm going to give you is that the area of a triangle is equal to 1/2 times the base times the height. And I've labeled what we could consider with these triangles here what the base and heights are. So base is here in blue, the height would be there in green. The base here is blue, the height is here in green. Some people will call that the height, but height is strictly vertical. It's not angled or anything like that. So again, this is why that's the base, and then the height is perfectly vertical like that. And again, here our base is at the bottom, and then the height goes from the base to the peak of the triangle there. All right, first example, we want to solve for x here, and they're giving us 3 different terms and values for the angles in this triangle. Looks like it's maybe a scalene. Doesn't matter what kind of triangle it is. They're giving us some angles. We have variables in the angles, and we know or can use the fact that all the angles in a triangle add to 180. So why don't we set up an equation that represents that? If I add this angle, and that angle together, I'm going to get 180. So I could write this as x plus 4x plus 80 equals 180. Right now it just becomes an algebra problem. So what was once looked like a geometry question, once you use some knowledge that you know about some of these geometrical shapes, they automatically turn into algebra problems, and it becomes a lot easier. So x plus 4x, that's going to be 5x plus 80 equals 180. Next, I'm going to subtract 80 from both sides. We'll get 5x is equal to 100. And then we want to get x by itself, so I'm going to divide both sides by 5. We'll get x is equal to 20. Now, if you wanted the exact angle measurements in this triangle, you would plug 20 back into x. So this angle stays at 80. This one would also be 80. And then this one over here would be 20 degrees. So this looks like an isosceles triangle, right? Because these two angles are the same, and then you have the one different over there. All right, next up, solve for x and for each angle. So this reminds me of the last one, very similar, just looks a little different. We want to solve for x, and we're given angles. And I know for a fact that if I add these 3 angles up, since it's a triangle, we're going to get 180. So let me write that equation out. So if I have 2x plus 3x minus 18 plus x, we're going to get 180. So now let me just combine my terms. 2x, 3x, and x. Those can combine to make 6x. And then we have minus 18 equals 180. I want to solve for x, so let me add 18 to both sides. Those will cancel out. We'll get 6x is equal to 198. So we're going to divide both sides by 6. I don't know what 198 divided by 6 is, so I'm going to put it in the calculator. And I'll get x is equal to 33. So there is, we've solved for x. Now they want us to also solve for each angle. Well, we're just going to plug that back in everywhere we see an x. So let's see. So this one's going to be 33 degrees. This one here is going to be 33 times 2, so 66 degrees. And then over here, 3 times 33 is going to be 99. And then minus 18 is going to be, what is that, 81? So if you wanted to check your answers, right, make sure everything works, add these 3 angles together, and you should get 180. So let's see if we did that. So we got 81 plus 66 plus 33 is 180. So this is correct. All right, next up we got a right triangle, and we want to solve for x and then for the area of the triangle. So this is going to be really easy, at least solving for x. We'll start there because we're given both of the other angles. I have 30, and then we know that that's 90, right? So if I add these 3 angles together, I'm going to get 180. So I can do x plus 30, let's fix that, plus 90 is equal to 180. 30 plus 90 is 120, so I'll have x plus 120 is equal to 180. And subtract 120 from both sides, and we'll get x is equal to 60. So this angle over here is 60 degrees. And then we want to find the area. So remember, area is equal to 1/2 base times height. So I've got my base over here. We can consider that bottom side the base. So that's 3. So we're going to plug that into B. And then we need this height up here. I'm using a different color. We need this. This is our height. Well, this is a right triangle, and we are given 2 sides. And so we can use Pythagorean theorem to solve for the 4th side. So we'll keep calling this h. But remember, Pythagorean theorem is a squared plus b squared equals c squared. So a and b are your shorter legs, and then c is the hypotenuse. So we could write this as, well, I'll write it originally first. A squared plus b squared equals c squared. Let's call the 3. That's going to be our a. So we'll have 3 squared plus b squared. Actually, we're going to be using h because we want to, we're calling it the height. So I'm just going to replace the b with an h. H squared equals c squared, which is going to be 5 squared. 3 squared is 9. 9 plus h squared, and then 5 squared is 25. I'm going to subtract 9 from both sides, and I'll get h squared is equal to 16. I want h, not h squared, so let's take square root of both sides, and we'll get h is equal to 4. So that's our height, and we actually could have just used the fact that we knew about special right triangles, 3, 4, 5 triangles. If I have a right triangle and one leg is 3 and then the hypotenuse is 5, I know for a fact my height or the other leg is going to be 4 because a 3, 4, 5 triangle is a thing. But you can always use Pythagorean theorem. It's never going to not work. So If the height is 4, and we wanted to find the area, we'll have area is equal to 1/2 base, which is going to be 3, times the height, which is 4. So 3 times 4 is 12. So the area is equal to 1/2 times 12. 1/2 times 12 is 6. So the area is equal to 6. All right, last one. So what we got here is saying that the perimeter of this triangle is equal to 38.58 meters. And we want to figure out the length of each side and then the measure of each angle. So looking at this picture here, remember these tick marks just tell us that this side is equal to this side, which is equal to that side. So this is an equilateral triangle. So this is helpful information. The perimeter, remember, equals 38.58 meters. And we're just adding up the side lengths to get the perimeter. So since this is an equilateral triangle, I can take the perimeter and divide it by 3 into 3 equal parts because each of these sides are the same length. So I'm going to do that. So the side length in this triangle is going to be equal to the perimeter divided by 3. So that's equal to 38.58, 58 divided by 3, which means the side length, or all the side lengths, are going to have a length of 12.86 meters. Right? You can check your work too. If you add this together 3 times, 12.86 plus 12.86 plus 12.86, you should get 38.58. So the next thing that they wanted to do is find out what the measure of each angle is. But remember, an equilateral triangle, not only are all 3 sides equal length, but the angles are all the same value. So similar how I did the solving for the side length, I could do that with the angles, right? I know that when I add all these angles up, I'm going to get 180. And since all 3 are the same measure, I can just divide that into 3 equal parts and get 60. So we could say that angle X is equal to angle Y, which is equal to angle Z, and all 3 of those are equal to 60 degrees.